JAXA H3, ALOS-3, launch coverage. Hey, Andy Saint, 70-month resub. All right, let's flip this over here, mix the audio in.
一方でそれを地上に送るという点が課題になってくるんですよね。
はい、そうですね。人工
ああ、そうですね。
地上局、アンテナがついててですね、衛星と通信をしたり、衛星に指令を送ったりする地上局があるんですけども、そこの上を通ったときにデータのやり取りをするというものなので、そこを通るときにですね、やっぱりデータが大きくなってくると、だんだんですね、せっかく取ったデータがタイムリーに送れないという、そういう
I introduced the technology for data transmission to be used for Earth observation satellites.
All right, we're just fast forwarding. Preparing to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding.
データ中継衛星を用いた通信システムはユーザー衛星と光データ中継衛星の間、光データ中継衛星と地上の間の2つの通信回線から構成されますが、そのうち前者の方の通信回線を光通信化したものがルーカスの大きな特徴でございます。データ中継システム自身がメリットを持ってまして、広い通信範囲が可能ということでございまして、トータルで送れる通信量が大きくなること。その広い範囲に対してどこでも
No, nothing yet, Aqualux. Tetra, I lived in Tokyo for 1.5 years. I can tell you what they're saying is
光データ中
Japanese.
継衛星化することにより、光のメリットである高速交代規制とか、またアンテナを小さくできるために機器を自体を小さくすることが
Furthermore,
可能
we
に
can
なります。
reduce the size of the antenna
光通信、とり
for
わけ技
R&D
術的難易
to
度の
promote
高い
optical
衛星間通信
communication
とい
in
う観点で
space,
は、
in particular the
欧州の
intersat.
中
Yep,
間
that's
と
way
なり、
too
世
fast.
界でフロントラインに立って軌道上実証を含む研究開発を進めてまいりました。その集大成として、
As a result, we can demonstrate the practicality of intersatellite optical communication. And this gives me great pleasure as a member of the Lucas development team. In addition, the wonderful images captured by ALOS-3 will be transmitted via optical communication for use as observational data by a range of people. I feel honored to be able to contribute to that process.
So that we watched the VTR about the communication system. What did you think? And so this concept has been around, but using optical communication shows that technology has evolved. So huge amounts of data, sending that on a timely basis. How does that help our lives? Is the issue that I want to learn more about. Okay, then let's ask the people involved in data usage of the IGS-3, how the data is provided, how they're expected to be used. Please watch this video.
Okay. PASCO was founded in 1953 as the first aerial photographer, and will celebrate our 70th anniversary in October. In addition to our original core business, we provide comprehensive geospatial information services to social issues by sensors mounted on Earth observation satellites, vehicles, and drones, and others. PASCO will engage in the establishment of the ALOS-3 ground operation system, operation of the satellite, and distribution of data as a partner of JAXA. We are promoting a wider usage of data acquired by ALOS-3. It can be used for map data creation, disaster countermeasures, smart cities, agricultural, forestry, and fisheries, and environmental monitoring. The observed data from ALOS-3 can be procured through PASCO's online program named Mitamuru. It allows users to easily search and view satellite data. By simply setting the scope and monitoring the area in an observation period, the users can place orders. ALOS-3 provides high-quality data that can be used for various purposes. We are confident this data will make the satellite commercial market even more dynamic. And we are looking forward to contributing to this trend. We will work with JAXA and other partners going forward to promote the wider utilization of satellite data. I don't know why that guy had a deep voice. I just just kind of pictured inside my head. This department conducts research from the implementation of intangible disasters to prevent and mitigate damage caused by sediment, which are caused by heavy rains, earthquakes, and volcanic eruptions. Specifically, we are working to understand how sediment flows on the surface to prevent them in an effective manner. Sediment-related disasters tend to occur in mountainous villages. We utilize the data to ALOS-3 is designed for a wide swath and higher resolution observation. A major change will be the satellite will help us measure the level of damage caused by sediment-related disasters immediately after the occurrence of an incident. In recent years, the imminent impacts of climate change has been a concern. As been pointed out, and there is concern, that the frequency and intensity of sediment-related disasters might also increase. The national government has been implementing measures to mitigate this and enhance the national resilience. We expect that ALOS-3 will be launched so we can effectively use the data observed in case of a disaster. Ooh, machine tools. It's okay, English is difficult. You ain't kidding. What?
地図の作成や更新のための技術開発を担う部署です。その一環で衛星データを利用し、効率的に地図を更新するための技術開発を行っています。国土地理院が整備している電子国土基本図の更新に画像データを使用する予定です。電子国土基本図はさまざまな地図の基礎となる我が国の基本図で、2021年9月に施行されたデジタル社会形成基本法において、公的基礎情報データベースという正確性や最新性が確保された社会の基盤となるデータベースの一つに位置づけられています。大きく4つのステップがあります。ステップ1は測量用航空機による空中写真撮影。次のステップ2が図鑑、地図を描く工程です。ステップ3が現地調査。最後が編集で、図化したデータに市町村名などの周期に関する情報を加えて作業が完成します。第一3号の解像度は初号機の 2.5 メートルから 0.8 メートルに向上しています。分解能が向上し、判読できる地物が増えることは地図の精度向上に直結します。今回第一3号のシミュレーション画像を2万5000レベルの電子国土基本図で利用可能か評価したところ、海、河川、湖の縁となる水害線や道路、鉄道、建物、植生、土地利用といった基本的な地物について。
Okay, dubs aside, 0.8 meter with synthetic aperture is pretty damn good. That's pretty good. Yeah. I think it's synthetic aperture. I'm pretty sure that's what he said. Hey, Tony. Off work. Got a pay raise today. Oh, hell yeah, man. Congratulations. 2.5 to 0.8 is a huge improvement. I mean, 0.8, guys. 0.8 meters. So what's 0.8 meters? That's like 3 feet? Something like that. No, less than that. Like 2.5 feet. That means, dude, like if you had like a for sale sign that was about this big, that satellite would be able to read it. Which is... yeah, that's pretty good. Like, that thing could read a billboard from space easily. Like, if it was at the right angle, you take a picture, you could read the letters on a billboard. No problem. Oh. Solid rocket booster this. This is them pinning the graphics on the SRBs.
And we saw the messages. At the time, there was anxiety and pressure. I'm sure that the operator...
We already have spy sats that do that, though? Yeah, Thomp, sure, of course. Oh, dude, the spy sats could read a newspaper from space, man. At the very least, dude. I'm pretty damn sure they could read the license plate off the back of a car. This is a commercial satellite. That's the difference. Or, well, publicly available satellite. Daiichi 3 is a publicly available satellite. So... like, this is something that anybody in Japan can go and access.
ALOS-3 journey to date is now in a video. Please watch.
Hey, baby. Booster-chan. Actually, Erudite, they say Esabi. They just say SRB. It's katakana. So, in Japanese, guys, they have, like, there's katakana, which is borrowed. Basically, they they have a bunch of words that sound like letters from other alphabets, and they borrow it, and those letters go together to make the word. So SRB is just SRB sounded with katakana letters. Yeah, so like some words don't translate, and you'll hear that when they're talking. Are there rocket launches privatized or government run? Government run, private contractor, Stroker. So believe it or not, H3 is built by Mitsubishi Heavy Industries for the Japanese government. So think of it like something, the Western equivalent would be Delta. Actually, Delta systems are kind of partially derived from this. So if the H2 and the H3 kind of look like a Delta rocket, yeah, they are from the same lineage, believe it or not. Yeah, so yeah, Mitsubishi makes this for the Japanese government. Yeah, Mitsubishi Heavy Industries. Car manufacturers in Japan are into everything. They're into all different types of things. So Subaru is Fuji Heavy Industries. They make all kinds of stuff. Just like Lamborghini makes tractors, right? Or Ford made tractors for the longest time. Ford made buses, tractors, semi-trucks, whatever. They really diversify in Japan a lot. So, yeah, Mitsubishi. Yeah, Mitsubishi builds that rocket. The car company. Actually, it's a subset of Mitsubishi. So it's Mitsubishi Heavy Industries, not Mitsubishi Motor Cars. Different company, but under the same umbrella. Kawasaki makes a 787 landing gear. Yeah, Yamaha. Yamaha is another good example. Yamaha makes car engines, and they also make pianos. Really good pianos, too, actually. Oh, there you go, Rojo. Yeah, I didn't know that, actually. It's pretty cool.
Heavy place thing.
Yeah, Yamaha makes keyboards. Yamaha makes motorcycles. Yamaha makes... they made the engine for the Taurus SHO in the 90s, Bandit. Yeah, the Taurus SHO has a Yamaha motor in it. Mitsubishi made airplanes. That's right. They do. They did make airplanes. Yeah, the A6M. Yamaha, don't they make music stuff? Yeah, in Japan, dude, if you're into industry, you're into industry. They make all kinds of stuff. Like, Yamaha makes everything, dude. They make, well, what are you talking about, Doc? All the best stuff comes from Japan. No wonder this transistor failed. It says made in Japan. Silly question, but is this live? Yep. I like my 90s performance cars to use marine engines. Good answer. All right, we're inside of 11 minutes here.
They can connect even with that, and we saw a lot of teamwork there. So let's look at the flight plan and flight sequence.
Wow. Man, those KSP2 graphics look great. Okay. The other thing is that we're inside of 10 minutes, guys. If you're here for the launch coverage, I'm going to run an ad. That's because if an ad popped up mid-launch, I would really find that annoying. So I'm just going to run it now to disable pre-rolls. I don't like running ads, but I don't like my rocket launches being interrupted by a damn Applebee's commercial either. So nothing against Applebee's, all right? That's eating good in the neighborhood, all right? But seriously, frick them. And if you're still here, hi. How are you? Yeah, I got you, man. No problem.
衛星分離後、第2弾はインド洋上へ制御落下を行います。
Yep, deorbit.
So let's look at the launch control center, how it is there. So what's the situation there?
Welcome back to the Talladega 500, and they're still crashing.
Working on their respective tasks calmly.
What's the diameter on the core stage? 5 meter. 5 meter hotel. Yeah. The center core is hydrogen with SRBs on the outside. It's like a little mini SLS, dude. Yeah.
Each of the tracking stations monitoring the status of the flying rocket. It also coordinates with the LCC and conducts the whole launch operation from here.
Yeah, it did bring.
So the LCC, the Launch Control Center, oversees the preparation to launch, and so fuel injection and the countdown.
Back from the ads.
And this RCC.
I mean, Chaos, did you at least get anything good? They added more boosters. Yeah. Yeah, they did. Yeah, there are range control cameras in 4 to 3. Interesting. Anytime we can watch a rocket launch salute is a good day. Wokai Kubo. This is supposed to be a relatively low-cost launcher, too. 50 million for 20 to 25 metric tons to Leo. Yeah, that's pretty damn competitive, actually.
Thank you.
I kept getting Bud Light.
Launch is approaching. From here, let's watch the live video from the launch pad and the live voice coverage from the range control center. It's now coming. It's soon. Let's watch.
Arigato gozaimasu. Hai.
480打ち上げ8分前です。現在各系ともロケット打ち上げの最終作業を行っています。また警戒区域の安全は確認されています。
It's 8 minutes to launch. All systems are now in their final operations. The restricted area has been vacated and cleared.
450
100% homogeneous erudite. It's all Japan.
440
Japan has the most picturesque launch site. This is Tanegashima. It's on the south. It's like between Kyushu and the most southern big Japanese main island and Okinawa. It's near there, so it's a very beautiful place, from what I can tell. I've never been
安
there.
全系準備完了。
Range safety system is go.
Okay, flight
車
termination
上
system
系
is
準備
online.
完了。
Range system is go.
408、407、406、405、404、403、402。
Yes, that's gonna go all the way to the end.
400
Oh, they changed it. It used to count down the entire thing before.
390
6 minute 30.
380 370
Yeah, it used to count down every single digit.
360
6 minutes.
打ち上げ6分前です。現在車上の天候は晴れ、気温摂氏18度、北の風毎秒3メートルです。
It's 6 minutes to launch. The current weather at the launch site is fine. Temperature is 18 degrees Celsius. Wind is 3 meters
Very
per
comfortable.
second from the north. The weather is still a go, and currently there is no constraint for launch.
There's another pad over
本
here,
日
yeah.
の
It's
打
a
ち
twin
上げ
pad
予定
launch
時刻
complex
は
bandit.
日本時間の午前10時37分55秒です。
Today's scheduled liftoff time is 10:37:55 seconds a.m. Japan Standard Time.
5 minutes. Look at the H2 mobile launcher on the right-hand side. Oh, yeah.
310、309、
Yeah, that is the H2 mobile launcher, isn't it?
306、
The other pad's over there, Bandit.
304、303、302、301、300、
5 minutes.
99、98、打ち上げ5分前です。
It's 5 minutes to launch.
95、94、衛星系準備完了。
Satellite system is go.
290、89、88、87、86、85。
Yeah, that's another ML over there for the H2. This is the H3 launcher. It's brand new.
78、77、76、75、74、73、72、71、270、69、68、67、66、65、64、63、62、61、260、59、58、57、56、55、54、53、52、51、250、49、
I'm sorry.
48、
Sounds like a song, man.
45、44、43、
Sorry. I don't know what you want.
41、
4 minutes.
39、自動カウントダウンシーケンス開始。
Automatic countdown sequence has
What do
been
you want from
initiated.
me?
現在、ロケットの管制は滝崎発射管制塔から行われています。
A3 is now operated under the command of Takesaki Launch Control Center.
22、21、220、19、18、17、16、15、14、
Sounds like something made me fall.
12、11、210、209、208、207、206、2段液体水素地上与圧開始。
Pressurization process of second stage liquid hydrogen has been initiated.
Okay, second stage tanks are pressing for flight. It's a Earth observation satellite chaos for sure, man.
86、85、84、83、82、81、180、79、
180 seconds.
3 minutes to launch.
76、75、74、73、72、71、170、69、1段液体酸素、液体水素地上与圧開始。
Pressurization of first stage liquid oxygen and hydrogen has been initiated.
First stage is pressing
機
for
体の
flight.
電源
What's
が
the
外
payload?
部から内部
Earth
に
observation
切り替えられまし
satellite?
た。
The power has been switched to the internal system.
Okay, H3 is not on the grid anymore. It's running off of its own batteries.
49、48、47、46、45、44、43、42、41、140、39、38、37、36、35、34、33、32、31、130、29、28、
Man, learning that Japanese finally paid off.
25、24、
そうですね。
23、
Hi.
22、21、
Why do they do this?
19、18、
2 minutes. I don't know.
16、
Never lasts. What's up, man?
14、13、
Yeah, I saw that, Lewis. Something was weird with that before, but now the systems are configured for flight correctly. I'm telling you, that IMU is no good.
104、103、102、101、199、
Hi, Hellfish.
97、2段液体酸素
No people on board.
開始。
Pressurization of second stage liquid oxygen has been initiated.
Okay, that should be all tanks.
87、86、85、84、83、82、81、80、79、78、77、76、75、74、73、72、71、70、69、68、
I hope so. I hope not, Methos. I hope we don't have that.
64、63、62、61、
T minus 60 seconds.
打ち上げ1分前です。
1 minute to launch.
55、54、53、52、51、
フレームデフレクター冷却開始。
Flame deflector cooling is initiated.
46、
Sound pad deluge systems online.
43、42、41、40、39、38、37、36、
Scary fast. I mean, it's a heck of a way to go out, dude.
ウォーターカーテン散水開始。
T
Sound
minus.
suppression water system at the launch deck is activated.
Okay. T minus 30 seconds. Sound suppressor is on.
24、23、22、21、
Oh yeah, Deadbringer for sure.
19、
It's a beast, man.
17、
Okay.
16、15、
At T minus
フライト
0.
モードオン。
13、
Flight mode on.
12、
Okay.
11、10、
At T minus 0, we should see the 2 center engines
Hydrogen
ignite.
purge igniter on.
And then at T plus 6,
All systems go for
we
launch.
should see ignition.
Main engine start.
Rough ignition. Engine start and lit. Oh, that one was different.
SRB3
There we go!
リフトオフ。
Solid boosters ignition and lift
Fly,
off.
baby, fly!
第3号搭載した H3 ロケット
They did the countdown different that time. It's different than the H2, but everything looks good there.
午前10時37分55秒に
The engine thermal covers are billowing in the
打ち上げ
wind.
られました
We have a successful liftoff for A3 launch vehicle test flight
Look at that
with
thing go.
ALOS-3 from JAXA Tanegashima Space Center at 10:37:55 seconds a.m.
Launch looked
on
great.
March 7th, 2023, Japan Standard Time.
打ち上げ以
Great
降
track.
ロケットの管制は滝崎発射管制塔から滝崎総合司令塔に引き継がれています
The operation control of A3 has been switched from launch control center to range control center.
Okay, range is now in control of that flight.
ロケッ
Next
ト
step in the
は
flight is
現在
maximum
10
dynamic
万
pressure,
相
which
当
we
の
learned
太
about
平洋
today.
上へ飛行しています
A3 is flying
Zoom
over
out.
Pacific Ocean to the
Zoom in.
east-southeast.
There you go.
打ち上げ後1分が経過しました。
It's 1 minute into flight.
Maximum dynamic pressure.
ロケットは正常に飛行し、地上局のロケット追尾状況も正常。
The A3 flight is on course, and the ground stations are tracking the launch vehicle, and all is good.
90 seconds in, everything looks good. SRBs do be like that, Cornelius. Power to weight can't be beaten with SRBs, man.
SRB3 燃焼終了。
Solid boosters burnt out.
Okay, their flame out. Booster's gonna tow the SRBs here for a little bit longer to get higher in the atmosphere for a clean separation. There's a good sep right there.
SRB3 分離。
Solid boosters separation.
ロケットは
Got double
現
sep
在
right there.
種子
Looks
島
good.
内之浦の地上局から追尾されています。
Currently, Tanegashima and Uchinora ground stations are tracking A3.
That's not good. That's not good. That's not good. She turned. Unless that was a weird optical illusion from the track, guys.
制御系飛行経路も正常。
The combustion of the first stage engine, altitude control, and trajectory are all nominal.
Are we sure
ロケッ
about
トは順調に
that? That may have just been an optical illusion, fellas. Like just the way the thing went through the track, but it did look like it was spinning.
約 1.6km です。
The A3 flight is on course. Current altitude is about 84 kilometers. Velocity is about 1.6 kilometers per second.
はい、H3 ロケット試験機1号機。
So we have been able to see a successful launch of the H3 launch vehicle thus far. And what
that ain't a
you're
dog
seeing
leg,
right
dude.
now is based on
It may have just been the weird
information that we
tracking
have
angle,
received
dude.
from launch vehicle replicated in CG, almost real time. And so a flight indicator
The track looks like a dog leg. Yeah, maybe, dude.
for public, which we call the
Bearing
FIP.
separation.
And it's looking at the direction that the launch vehicle is traveling at and also showing the height. And it is indicated as a line. And the data obtained from the launch vehicle is actually reflected into this. So it's showing the trajectory of the launch vehicle. So the satellite fairing separation has been confirmed. And what you can see is on the screen is X plus, which is the time lapse from the
Holy balls!
ロケットは順調に飛行を続けており
That, yeah, no, that was induced. Yeah, yeah.
175km
Whoa, that's a strange trajectory. Yeah, no, that was, yeah, dude, that was on purpose. It took, dude, it,
175 kilometers. Velocity is about 2.4 kilometers per second.
it drifted.
And
Nani?
towards top left, you can see the altitude and
Kansai
the
drifto!
velocity. So we're traveling at more than 200 kilometers above underground. And on the left is the
Holy
speed.
balls, that was an induced turn.
So what
Jeez.
that's so it was accelerated to 28,900 kilometers an hour.
That is an
eventually.
insane
And
launch
so,
trajectory.
we are
Holy
almost
crap.
at the completion of ignition of first stage
ドリフト
engine
ラケッ
now.
トはい Holy crap!
第1段エンジン燃焼停止。
First stage engines cut off.
There's
第1
main
段
engine
第2
cutoff.
弾
Stand by for stage separation.
First
They do
and
have it on
second
board.
stage separation.
Okay. We gotta watch that number. That number should start going up. Unless we have low TWR on the second stage, which I highly doubt. The payload is light.
はい、まあ2段エンジンがこの後
So 343.
And so
These numbers are right. Those are real numbers. That's the telemetry right
I
there.
heard the ignition start announcement as yet, but at ignition at 16 minutes 36 seconds, it will continue to ignite to take the satellite
That is an
into the
insane
orbit.
trajectory. I've seen SpaceX do stuff like this, Rain, but nothing like that.
ひとまず
So we have seen the launch of the
You can, TJ,
H3
sometime.
launch vehicle, test flight number 1. So that
Right,
in
Cornelius,
itself
you
has,
see that? That was on purpose. You got to be kidding me.
Made me
Why
feel
not-
reassured.
why not
so
just
we
turn
can
the
no longer
rocket
see it in the
south?
sky.
I don't get
because
it.
of the fine weather, that we were able to see it quite high into the sky. We were able to see the B3 separation.
It had to have
But,
been Bunta. Bunta had to have been
the
driving.
launch vehicle is a delivery service, so we must separate the satellite. Otherwise, we will not be able to call the entire mission a success. So at this point in time, we still
It's got to be
cannot,
range. It's got to be the
reassured
range
as yet.
super. The range made them fly that
And the
trajectory.
people in RCC is keeping a close watch on the...
So, guys, if they go back into that map view thing, I'll be able to tell you if that second stage ignited or not. A lot of the times with the second stage, you have low thrust to weight ratio, so you can coast to apogee. And what they deliberately do is go past the apogee for better pinpoint orbital insertion. So even though that second stage ignited, the numbers for velocity would still be going down because the first stage doesn't have enough TWR, right? But see, that number is not going down as fast now, and they're still going up, meaning that first stage put them on a super high trajectory. So the apogee's got to be around, like, if I had to guess, it's probably 550, maybe 600. We'll see. You know that they're coasting to apogee right now because that number is going up slower and that number is going down slower. If they go past apogee, this number will start going down and that number will start going up. But yeah. Okay. Yep. They're getting to apogee. Let's see. Let's see if that number... What a freaking trajectory that was, man. Unbelievable. I've never seen anyone do that before. Crash course me. Look at the trajectory, Rec. Dude, I thought the rocket spun out of control. No. They did an insane coplanar anti-normal burn, and the rocket drifted. I can't make that any more clear. The rocket drifted up into space. So apogee's been pushed above 550. We just got to make sure. Let's see. If this number starts to go down, that number will start going up really, really fast.
To confirm the situation.
It was on purpose, Piff Cube. Yeah, I was supposed to do that. Unbelievable. I've never seen stuff like that before.
The second stage engine ignition has not been confirmed yet.
Yeah, that's not good.
We continue to confirm the situation.
Yeah.
So we have not been able to confirm the ignition.
Well, Jonathan McDowell, so he keeps track of like stuff flying around in space for, I think it's planned. Who's John work for? But I forget who he works for. This trajectory is to go around the Philippines, I'm pretty sure.
And so the elevation is at 625 kilometers, but the velocity is coming down. But is this the actual situation? We would like to await for updated information. We are confirming the situation right now, and so if you could bear with us. As soon as we receive updated information, we will convey that to you.
Well, they're at apogee now, 629. No, 630. Almost there. I mean, Liquid, it could be a low TWR upper stage, but yeah, if they go past the apogee, so the highest point in this suborbital arc that they're on, and if that speed starts going like up really, really fast, they may have not had a good second stage ignition. It also could be stage TWR, but at this point, I'm kind of... You don't lose... Yeah, exactly, Liquid. Yeah. It's possible. It's a new rocket. I'm not too familiar with its ascent, but also... I think you might be right. Yeah, he's out of Harvard, 10. I forgot if it was Harvard or MIT, but yeah. Use the space, please. Is there a self-destruct on board? Oh, don't worry. Watching the atmosphere will do that when it comes back down. If it re-enters, yeah, that you don't need a self-destruct system when you're going that fast. The atmosphere will do it for you. In fact, most rockets disable their flight termination system once they get past a certain velocity because of this. You don't need a flight termination system. The atmosphere will do it. Even if that failed, that Tokyo drift was sick. That was, dude, that is one of the gnarliest things I've ever seen in rocket science. That's so freaking... Did you see that thing turn? I ain't even mad. Joe, did you see it drift? The rocket straight up... Dude, I gotta go back. Hold on. Hold on a second. Watch this, all right? Watch the core stage. Watch this.
Currently, Tanegashima and Uchinora
Look
ground
at-
stations are tracking A3.
Oh my gosh, it's drifting! That rocket is drifting! That's freaking sick! What the frick? Holy balls! Did you see that? Not that I mean it's drifting! What the frick, dude?
The combustion
Guys,
of the first
I'm
stage
not sure if it's supposed to do that.
trajectory are all
That Hellfish, that may have broken something. That dude, I don't know if it liked that, dude. I don't know if it liked that at all.
This is an announcement from the Takesaki Range Control
on.
Center to all launch operators and personnel. The second stage engine ignition has not been confirmed yet. We continue to confirm the situation.
繰り返します。現在、第2弾エンジンの着火が確認されておりません。引き続き状況を確認中です。
Yeah, Tan, that's right. H3 can
The
have 3
second stage
engines.
engine ignition has not been confirmed yet. We continue to confirm the situation.
Yeah, Rojo, I'm not sure if that had to have been on purpose. I don't know. Look at the trajectory plot in that one graphic. Insane AOA seems that... Yeah, no, Vulcan, I'm pretty sure that radial burn right there after SRB separation was induced. That was on purpose. I'm not sure the second stage liked that so much. But, yeah. Was that an expensive satellite? Synthetic aperture radars, yeah. I mean, Atlantic, if you have to ask, yeah, it's probably expensive. Was that expensive? Is it heavy? Yes, then it's probably expensive. Put it down.
はい、今放送がありましたが、
So as was announced,
Not good.
ignition of the second stage has not been confirmed. The situation is being checked and confirmed. To repeat, second stage
Not
ignition has not been confirmed, so the situation is being confirmed. From where we are, we cannot see, so all we can do is wait for information to come in. But we're watching the CG and we're talking over it. The separation of first and second stage, we were seeing that the signal was sent, but the second stage ignition start, we did not hear.
ちょっとお待
ロ
ちくださいね。
ケットは
Give us a minute.
ミッションを達成する見込みがないとの判断から指令破壊信号を送信しました。
今放送が入ってます。ちょっとお待ちください。
A destruct command has been transmitted to A3 because there was no possibility of achieving the mission. We are confirming the situation.
That sucks.
繰り返します。ロケットはミッションを達成する見込みがないとの判断から指令破壊信号を送信しました。
A destruct command has been transmitted to A3 because there was no possibility of achieving the mission. We are confirming the situation.
That sucks. You don't wish that on anybody. It's not fun, dude. There's thousands and thousands and thousands of people that come together to make this thing work. It's a real gut punch when it doesn't. That sucks. Dude, that Ascent, though, was dope. That was so cool. The style points, though. Yeah, man. That's terrible. Dude, note to self. 90 degrees, 10G turn is not that bad. I don't know. What do you guys think? I think that turn was on purpose, but I'm not sure if it...
管理主任より打ち上げ作業関係者に連絡します。状況については
Yeah, Booty Raider. So yeah, they meant to do it, but I'm not sure it was supposed to do it that quickly.
これをもちまして本日の H3 ロケット
Yeah, Cartoys.
の打ち上げ実況放送を終了します。
The status of A3 launch vehicle number 1 will be announced to all launch operators as soon as it will be confirmed. We are ending today's launch status report.
Oh no.
繰り返し
Yeah.
ます。状況については分かり次第
Yeah,
打ち上
Gaffleg.
げ関係者に別途連絡いたします。これをもちまして本日の
Yeah,
H3
Will,
ロ
I'm
ケ
with
ッ
you.
ト試験機1号機の打ち上げ実況放
It's
送
just a real kick to the balls, isn't it?
The status of A3 launch vehicle number 1 will be announced to all launch operators as soon as it will be confirmed.
I think you're right,
We are
Everlast.
ending today's launch status report.
Ah, that sucks, man. You know, you wouldn't want to wish that on nobody, dude.
大丈夫です。はい、今放送が入り
As was just announced,
ロケットはミッションを成功する
rocket could not complete its mission, so destruct command was sent. It was decided
guy's
that
face
the
says it
rocket
all right
could
there.
not complete its mission, so destruct command was sent. Destruct command is we send the signal,
Sage.
and there
It'll
is this
re-enter
device
Ducklington.
that is activated to destruct the rocket. And then it will not fly any further and it will come back down to Earth. So we were watching in the CG. First stage combustion was completed, and we could see that command was sent to separate the first and second stage. 5 minutes 27 seconds. The second stage engine was started to ignite, but in the CG that signal was not received. We were not able to confirm that. So what happened there? Something that we have to investigate, looking at all the data. So during this broadcast, it will probably be difficult to explain in detail all the phenomena. So please, we'd like to communicate to you through the website or through other media. So we cannot expect more news
It's
to
a
come
formality, Kirinov.
in. And so we would like to conclude the live broadcast for the H3 first test flight. Very regrettable this happened. It's a test vehicle, so there were various challenges.
Don't need to be sorry, man.
And there were some risks, of course, because it was newly developed. So going forward, we're going to investigate the cause. Yes, we need to identify the cause and then reflect it in the next test vehicle. That would be our mission. So as for the detailed information, please visit the JAXA website. Information will be provided there. Thank you for watching the live broadcast. Thank you.
Their rocket blows up on stream and they apologize. Frickin' Japan, dude, I swear. Yeah, I mean, guys, I don't know, man. That's cool that trajectory did what it did, but if you...
Tranquility Base here. The Eagle has landed.
Roger, Tranquility. First attempt at Rocket Kana. Yeah. That sucks, dude. So everything looked real freaking good. Real good. This track is money, dude. That thing is right down the pipe. It's perfect. And then it does this induced turn here. Watch. I mean, it was definitely on purpose. So the SRBs separate. It drags the SRBs a little ways up into space. And then watch the core. Watch the core stage. Look, it's turning. That right there is not... Dude, if it was any other rocket, I would say that's failed. See what I mean? But apparently that's an induced maneuver so they can launch up and then turn around the Philippines so rocket parts don't come down over populated areas. I'll admit, though, I've never seen a rocket do that. A drift, literally a drift through space. That is drifting. Which I get it, Initial D and all. I love Initial D just as much as the next guy, but that is... That's a lot of drift. I don't... Yeah, the boosters performed great, but Phil, that... So, if they were doing a radial... Okay, so that's radial in, all right? If they were doing a radial in burn, as this suggests, right? So what's going to happen is that you're not going to see much of a velocity difference. Velocity will not be going up very, very much. Yeah. Like, that number is not going up very fast. So that does jive with what's going on here, but doesn't it look like the engine shuts off after the turn? It's hard to tell, Laz, yeah. But see, here's the thing. We get down over to here and see that turn? That trajectory, right? See this? See that big right-hand turn? That trajectory jives with that drift. That is the trajectory that it would fly if you turned 90 degrees after SRB set. That's right. That's exactly what it would do. That's the trajectory to a T. Now, over here, let me get out of the way. They do show what appears to be an onboard here, but I'm not sure if that's old footage from an H2 or what. Their staging velocity was 12,732 kilometers an hour. Let me just do some math out here real quick. Kilometers an hour. We want to get that in meters. And then get it into meters a second. You know what? We'll do this the easier way. kph to meters a second. Yeah. Okay, 3,500. That's good for a stage performance. That's pretty all right. That's a good staging velocity right there. Yeah, no second stage ignition. Yeah, no good. And once again, I don't know if that is actual footage. I don't know if that's live. It might be. That's the last we saw of it. It's a render? You think so? Well, that's definitely a render, right? This is a render. I'm talking about this thing over here. Yeah, maybe. Let me see the next animation. It's a render. Yep, that's a render. We're losing velocity like crazy. Second stage never ignited. Yeah, it's a render. Absolutely. What is this test trying to achieve? So it's test flight 1. This was the first flight for this rocket, guys. See TF1 up there? H322S with and it had a payload aboard for the first test flight. Sometimes rockets do that. ALOS-3, which is the Daiichi 3, well, was the Daiichi 3 synthetic aperture radar satellite. It's an Earth observation satellite. used for like detecting climate change and predicting climate disasters, stuff like that. Yeah. So in terms of the self-destruct system, guys, the flight termination system is armed, but as a formality, they send a command to detonate the rocket. But dude, you don't need to worry about that. It already burnt up by the time they sent that command. Yeah. Yeah, that thing already croaked. I mean, yeah, that sucks, dudes. But hey, it sucks. But this is how this business works, man. You know, your rocket blows up in Kerbal, right? It's annoying. Imagine how much worse it feels when it happens in real life. It's tough, man. It's a tough industry. It's tough. It's science. Yeah, they'll be back. Yep. You know, now what they're gonna do is they got to comb through that telemetry and they got to figure out why that second stage didn't ignite. You have to try and figure it out. Here's the trouble. You have to figure it out, and your second stage, what's left of it, is at the bottom of the ocean, and you ain't finding it anytime soon. So you have to kind of make sense of of the telemetry from now on, which this is hard to do. It's a hard business. But rockets, the fortunate part about that is that rockets are downloaded. Rockets don't really have like a black box per se, like on an airplane. They don't really have a flight data recorder like that's recording locally. I mean, some of them do. But rockets actually download that data in real time. The telemetry gets downloaded to the range control center on most rockets. I'm willing to bet that H3 is no exception to that rule. So the fortunate thing is that they have the black box. They have all the telemetry pretty much right up until staging. So if you have the second stage telemetry, you can make a pretty reasonable what's called a fault tree based off of that, and basically figure out what went wrong. It's pretty. I'm not going to say that it's easy to predict. It's just you have the data to actually do it. It's hard to do. It's hard to find the fault tree. Go bug fixing for your rocket. It's tough, man. Can we see the ignition and liftoff again? Well, sure. I mean, it was a great ignition, great liftoff. Everything was real good. It looked textbook up until that point. All right, here we go. Yeah, dude, I mean, this stuff happens, Doom. This is why I don't let stuff bother me in Kerbal. This stuff happens in real life, man. It happens all the time. More often than people think.
Hydrogen purge igniter on.
Anyone ever call me a nerdy Charlie Day? I've never gotten that one before, Pop-Tart, but I'll take it. I'll take that. Yeah. Charlie's cool. I like that guy.
Main engine start.
See, that's textbook, man. That looks perfect.
Boosters ignition
Real
and
good.
liftoff.
Yeah, Orion has flight data recorders, Rev, right? Because you get it back. That thing wouldn't have a flight data recorder on it because it's an expendable vehicle, right? So
For A3 launch vehicle test flight with ALOS-3
It's the new Prime
from
sub, by
JAXA
the way.
Tanegashima Space Center at 10:37:55 seconds a.m.
That's the
on
pad
March
purging
7th,
system, guys. That's normal.
2023
Hey,
Japan
Yaplees.
Standard Time.
Thank you, buddy.
打ち上げ以降、ロケットの管制は滝崎発射管制塔から
Did it blow up? The second stage didn't ignite, protected, it re-entered. But damn, dude, was that money up until that point? That's perfect right there. That's perfect. That's a beautiful rocket. Yeah, no, solid side. It's the Japanese. Of course not.
Seconds a.m. on
Think
March
Japan rolls like that? Hell no.
Japan Standard Time.
打ち上げ以降、ロケットの管制は滝崎発射管制塔から滝崎総合司令塔に引き継がれています。
Yeah, don't be fooled by those small boosters. They pack a punch, dudes. We were talking about how potent SRBs are. Personally, I don't mind them. I think SRBs are great. Kind of sucks if you're trying to do reuse, but dude, those little boys pack a punch right there. That thing is like, those SRBs are like the size of a Greyhound bus or like a big coach bus. That's what the size, dude, they are not small by any means. They look tiny on the rocket, I know. But that's the size of a freaking semi-truck, those things. They're huge.
The operation control of A3 has been switched from launch control center to range control center.
That's 2 Greyhound bus versus like SRB. That's 2 Greyhound bus worth of SRB attached to the side. She's a beast, man. They were sending a observation satellite, Solitide, a disaster observation satellite, public resource satellite, so Earth observation. City Skylines 2 is coming soon. Oh, Nick, believe me, I know.
The H3 flight is on course, and the ground stations are tracking the launch vehicle, and all is...
They ain't growers, they showers? Nah, not Japan. Japan knows how to space pretty damn well. It's just new rocket, guys. New rocket, who dis? This stuff happens. But I will say this, man. I will say this. There's not a lot of rockets that can do that. Watch the core. There's not many rockets that can do that and survive. That is an insane trajectory maneuver. Unfreaking believable. That drift is on purpose, man. That's supposed to do that. Unbelievable. As they spin, the light from the engine disappears. Well, did it survive? Yeah, it's the first test flight of a new rocket. SpaceX's first test flight of a new rocket with Falcon 1 exploded. Like, what do you want? Didn't even make it that far. New rockets, dude, it doesn't matter how much experience you have. New rockets can fail. That's a thing. They do that turn to avoid populated areas? I suppose, dude, but I don't know if it was supposed to rotate that much, guys. Like, look at this damn trajectory. Now, I will say that a turn like what it did is supposed that's what the trajectory would look like if you turned like that. But oh man, it may have over-rotated or something. Makes me wonder how a rocket would react like that in KSP. It'd work, dude. Yeah, sure. Yeah, I don't know, dudes. Yeah, Aqualex, exactly. I mean, so here's the thing, guys. You're saying the engines look like they flamed out, but you're still seeing velocity increase like crazy, and your apogee is going up. The engines are still on. And we know from the last H3 stream that those are real numbers. It's not just some animation. This is an animation. Those numbers aren't. We know because the IMUs weren't configured on the last flight, and we saw that thing bouncing up and down in the wind. Believe it or not, the rocket was going back and forth, and the altitude indicator was reading 85, 80, 85, 80, 85, 80 as the rocket was swinging back and forth in the wind. And then it switched to configuration, and then it worked better this time. Yeah, we could see it from the telemetry, which was kind of funny. But it's very clear right here that this thing is... So those numbers are real. We know those numbers are real. It's very clear that the second stage, or the first stage is still on. Absolutely still on. Hey, Kieran, 5-month resub. Thank you. This is I don't know if the graph is necessarily telemetry driven. I know that those numbers are right. And obviously the timer is correct. Yeah, exactly, Pleasant. We watched the second stage bleed off 3 kilometers. Or 3,000 kilometers an hour. Yep. During the broadcast, they said that the graph is telemetry driven. So, yeah, okay. If it's telemetry driven, I'm wrong then. But see, here's the thing. A turn like that, that's what the trajectory would look like, Toothless. So, yeah, I mean, if it is telemetry driven, then, yeah, unbelievable trajectory. Here, let me see. So, let's take a look. First stage is still on. Still on. Still on. The second this number starts going down is the second the staging happened. Right there. Right there. First stage made it up to about 3,500 meters a second right there. That's right. That's about how much delta V first stages have. That's right. If you're a Kerbal player, an entire H3 could make it into space with just the SRBs on the side. Make of that what you will. Yeah, right there. There's staging. The number starts to go down. See, that number is an apogee right there. That number's not apogee, so that's current altitude. So it's really, really difficult to kind of see what the insertion apogee was. But yeah, that's not, yeah, that's no good. What type of benefits does JAXA look to gain with this? H3 has a configurable engine section. You can launch it with 2 or 3 engines in the core stage, Huzzah. You can also bolt 2. It can get up to 2. Well, I don't think it can do 4. I think it can only do 2 SRBs. But you have a configurable engine section, which is great. Which makes it offers a bunch of different payload varieties. So like different versions of the H3 rocket, like the most powerful one, 3 engine 2 SRB should be able to move some stuff out to Gateway. With the HTV-X vehicle. That's what they're looking to get. Yeah, see. Anytime these two commentate, this guy, it's very easy to tell if something went wrong from that dude. That guy always is like, yeah, he's not happy. He knows. That dude knows. Kotani-sama. He knows. Yep. See, he's like, yeah, everything's good, but then he looks back at the telemetry and goes, hard on his sleeve, dude. It's dude, digital. It's hard to have a poker face with this stuff, dudes. 2 to 4 SRBs combined with 2 to 3 engines. That's what it was. I wasn't sure if it was 2 or 4 SRBs Deadbringer, but yeah, I mean, either way, H3 is a monster. It is a monster little lifter. Yeah, see, he knows. I don't think she does. He knows, though. I mean, look, dude, yeah, no. He's looking at the telemetry going, ah, frick. Yeah, he's not, yeah. That's no good. That sucks, dude. Japanese version of hand on mouth looks like complete dejection. Dude, I've been there, man. In Kerbal. I've been there many times. We hit that spot today in Kerbal. We couldn't get the damn thing to fly. And dude, it hurts in Kerbal. Like, it's so annoying in KSP. I can only imagine what it's like in real life. That probably is like the worst feeling ever. Like, dude, it's like your puppy got shot or something. Like, it's like it's like that tier. It's gotta suck. Like, it's not fun in KSP. Any Kerbal player knows this, dude. When you're trying to do something in KSP, it just doesn't cooperate. And it just doesn't do what you want it to do. It's so frustrating. You know? I can only imagine what that feels like in real life. That's probably the worst feeling ever. Oh, my goodness. There isn't enough whiskey for that situation. Huh? Yeah, right. Yeah, nobody got hurt, Willie. And you learn from the test, dude. It's only bad if you don't learn anything. So I'm sure the Japanese are resilient. They're resilient folks from what I've seen. Been there. Resilient folks, dude. They'll figure it out. I know they will. Protected? No, I'm good, thanks. It really sucks for a rocket that launches a few times a year. Yeah, they'll figure it out. Did you read the conclusions from Arianespace about the Vega C launch failure? Nozzle burn through, Salyut. Interesting, right? Nozzle burn through. Dude, that thing ejected the entire rear subassembly, just like we predicted. It's really easy to spot, dude. But that's the thing, dude. That me saying, oh, the entire nozzle ejected is like someone watching a NASCAR race and the big crash happens and going, yeah, that's probably not good for the people that are in that crash. It's like, yeah, obviously. You got to figure out why. That's the hard part. For reals, you can see the info in the graphics before they say it. Yep. Easy to spot, hard to prove. Bingo. Yep. Knowing that it failed is pretty dang easy because the thing usually blows up. That's that's how you know it failed. Like, this rocket is no more. It has ceased to be. You know? Did we watch Tesla Investor Day? No. The guy turned right. There's your problem, huh? Dude. That I'll tell you, I want to see it again. That is one of the gnarliest drifts dude, I've never seen a rocket do that before. The only thing that even comes close is the time that SpaceX decided to do like a 20-degree on-orbit plane change with Falcon 9, where the second stage did that. It did exactly that. But that was already after it went into space. See, last for a question? Just type it again from now on, Buck. With H3, are they using a brand new second stage design too? Or is it the first stage design that's significantly changed? Well, it's very simple. You see, Buck, let's see. SRB3. 0, 2, or 4, 2 or 3 LE9. Second stage is the LE5. The second stage seems to be more similar to the H2. At least it's using the same propulsion. Look at those specific impulses. Hydrogen, man. I'm telling you, hydrogen is freaking cheating, dude. The LE5B is... Let's see. What is it? It's an upper stage propulsion system for the H1 and H2. It's a bipropellant LH2 hydrolox. LH2 liquid oxygen, so it's a hydrolox design. What's its cycle? Hold on. This one has an LE5B3, so we're down here. For the new H3 vehicle, the veteran design of the LE5B was once again revised to meet requirements of the H3 and ensure a stable supply of parts over H3's lifetime. Performance was improved and costs were to be lowered, all while keeping developmental risk as low as possible. Obsolete parts that were becoming hard to acquire, such as the electronics and the engine controller, were to be replaced with modern components that could be reliably sourced for years to come. And the manufacturing method for the combustion chamber was to be likewise updated for similar reasons. The liquid hydrogen turbo pump and turbine nozzle were to be updated for H3's longer mission duration times, and the performance of the liquid oxygen turbo pump and fuel mixture was to be improved. Yeah, it's always the same crap, different day, Buzz, huh? Engine certification for flights on the H3 rocket is currently ongoing. Huh? All right. Yeah, these numbers. This is like an RL10. What is it? It's using an expander. Yeah, expander bleed. Yep, it's like an RL10. It's actually a pretty hardcore version of an RL10 right there. Those are really good numbers for an expander cycle. Well, it's expander bleed. But yeah, so I mean, that's pretty good, man. Wait, expander. Hold on. The major difference is that the operation of the engine was switched from a gas generator to an expander bleed cycle. Let me just click on this just to be sure. Expander bleed. This operation cycle is a modification of the traditional expander cycle. In the bleed or open cycle, instead of routing all heated propellant through the turbine and sending it back to be combusted, only a small portion of the heated propellant is used to drive the turbine and is then bled off, being vented overboard. Ah, okay. Yep. Without going through the combustion chamber. The other portion is injected into the combustion chamber. Bleeding off the turbine exhaust allows for higher turbo pump efficiency by decreasing back pressure and maximizing pressure drop through the turbine. Okay, open cycle expander. Got it. Yeah. Yeah, that's how it can make more pressure than the RL10. Yep. So, all right, little bit on expander cycles here, fellas. You want to learn about this? Here's how you do it. So, you have the fuel. The fuel goes through a fluid impeller. Okay, so the hydrogen, it goes through a fluid impeller. And these are the control valves. All rockets use control valves. They're usually pneumatically driven because having electrical stuff around fuel is not a good idea unless it's in here. True story. So it goes through the valve, and then it goes through cooling channels in the nozzle to keep the nozzle cool to prevent it from melting. That heated hydrogen then goes up, right, into basically a proportioning valve, I would guess, and most of it goes into the turbine. The turbine is on the same axle as the fuel pump and the oxidizer pump. Some of that gets recirculated into the combustion chamber, but most of it gets dumped overboard. That's an expander bleed right here. If this was an RL10, all of the turbine would go into the combustion chamber, all of it. Yeah, so with this design, you're going to generate higher thrust, but it's going to be a little bit less efficient, but you're going to generate more power. You're going to make more thrust this way. Because they said because of back pressure, you had to work, if you know, with this open cycle, the back pressure in here, they're talking about the back pressure through the heat exchanger. That's what that means. Yeah, it's like back pressure in exhaust. Same idea. Interesting. So, in terms of the LE5B3, that was carrying a bunch of new components. So, here's the thing. If we go back and look at that footage, I'd have to let's just check something real quick, okay? Let's look. So, all right, we can extrapolate some data here if we really, I mean, we might be looking too much into it, but let's see. So let's back it up a little ways here. Let's watch this. So if there's some kind of problem with the engine, if it failed to start but tried to, you'd see some bump in the telemetry here. You'd see the numbers start to accelerate again, right? If, like, they stop, they start going down, and then they bump and then start going down again, that means the engine turbo pump started spinning. So that means I would contend to say that's something wrong with mechanical. If we don't see any bump in acceleration post main engine cutoff, electronic. I mean, that's just a guess, but let's see. Let's see what we look. Let's see what we can see here when we look. That's what I was trying to say. The LE9 is also expander bleed. All right, let's take a look. So this thing gets up to about 3,500 meters a second, which is a good staging velocity. That's right. All right, let's watch this in slow-mo, okay? Let's go this down to 0.25. Just back it up just a little bit. All right, so peak speed should be about 12.9. Okay, that's staging right there. 12,970. That's staging. Let's see if this number bumps at all. Nope. Nope. Nothing. That number is falling at a steady rate, which means we're decelerating to apogee. Stage didn't even try to start. Look carefully. It slows, then it falls faster. Let's take a look again. Yep. Yeah, Aqualex, I see it. Yep. It ignited for a second. It definitely did. No, I retract my previous statement. You're right. It ignited for a second. Watch. So right here, at 12,969, right? This thing takes a couple of seconds to get down to 12,960. That is consistent with the low TWR upper stage. When it gets down to 12,960, that's when the velocity starts going down like crazy. Watch. It could be ullage thrusters. It could be stage separation. That's right. It could be the impulse from stage separation. That's correct. It could be that too. I'm not ruling that out. But yeah, if there's some type of ullage motor, let me just check to see that staging was on time. Sometimes checking the timing with the events is really, really good to check. Fellas, look. T plus 5 minutes. This graphic says that staging was supposed to occur. So 12,970 is the fastest we saw it go. So that's main engine cutoff, I would guess, right? We're off time a little bit. So, okay, why does that mean anything? Maybe it's just a little bit late. That's fine. Right? Right? That's fine. No, that's not fine. No, that's not fine at all. That's not fine at all. You miss your main engine cutoff mark by a couple of seconds, your second stage is not making it into space. Yes, rockets are strung out that much. Yes, absolutely. Oh yeah. Oh yeah. I'm noticing there's some off-time events. So this also says that SRB separation is at 332. Let's back it up a little bit and see. Or no, that's fairing separation. It says SRBs are at 156. Let's check. Okay. Yep. SRB separation was on time. That's correct. No, Arctic, the ignition sequence was different than what they usually do, guys. The ignition sequence with H2 rockets, they fire the engines at T-0 and then launch at T+6. This thing did it more like the shuttle. The LE9's activated at T+6. Rofi ignition was at 10, so radial outward firing igniter, or just the sparklers to purge hydrogen. So the pad hydrogen purge system is what they called it. That fired at 10. Engines on at 6, booster ignition at 0. That's much more like a Western launch, to be honest with you. ALOS-5 Cygnus a few years ago came within like 3 seconds of Centaur propellant margin to not make orbit. Great example about how even a 3 to 4 second S100 performance can nearly end a mission. That's a good example, Vulcan. Oh yeah, absolutely. I'm seeing stuff off time here. Now, fairing separation, I don't know. Like, that doesn't really matter. I mean, unless you held it for a couple extra seconds, you know, your delta V margins could get screwed here, but so this thing said that we were supposed to enter staging at 456, MECO at 456, stage separation at 504. But it's very clear at 456 that the engine is still burning. Yep, you're off time, big time. Not by much. Hold on. Let me look at it again. Oh, sorry.
So it was accelerate to 28,900 kilometers an hour eventually. And so we are almost at the completion of ignition.
Yeah. Staging was too late. I don't know if that has anything to do with it. That's not a good enough reason to say, you know, oh, the second stage didn't work, you know? Maybe transient shutdown thrust. Dude, I don't know, man. It keeps accelerating. I'm looking for changes in that number going up, like changes of the rate of the number correlative to seconds. So, like, if you look, we're nerding out here, dudes. We're doing some hard math, like not hard math, but so that's supposed to get staging here at 12,680, right? We can extrapolate acceleration from this, Vulcan, or at least we should be able to, right? So 1256, we're at 12,600, right? $466, so that's 134. If you're accelerating at 134 kilometers a second, right? I think so. I think that's right. Let's go to 456 and let's see if the acceleration is different. So there's the tick to 456. We're at 12.6 on the bat. So if we're still accelerating, right? If we're still accelerating, this number when we get to 457 should be 12,730 or something, right? If we're accelerating at the same rate. That's pretty damn close. Kilometers an hour a second. Yeah, boo, exactly. Yeah, I forgot the extra unit in there. Yeah, that's pretty close, man. What do you think? Yeah, exactly. Boo Boo is right. It's not kilometers a second. It's 12,000 kilometers an hour a second, which is, that's a stupid way to say that. That's why they use meters a second for velocity instead of kilometers an hour. They lost the second stage, yeah. Yeah, that could indicate a throttle down for separation, Mythos. Yeah, you're absolutely right. Let's see. So we're talking about 120 kilometers per hour per second, right? So let's, right when that 57 ticks over, okay? So let's add 120, 130, somewhere in there. So that gives us 854, 12,854, should be at 458. Yep, that's close enough. I mean, Vulcan suggested residual thrust, and that could be right here, but we're accelerating at the same rate. That is the fact that we're seeing such consistent acceleration, even though we're measuring it in the most ridiculous way, kilometers per hour per second, right? The fact that we're seeing consistent acceleration way past the T0 mark indicates something is wrong. Something is wrong because the rocket, once again, I talked about this in detail this afternoon. I'm not trying to be a jerk about this. So, guys, this thing says staging at 456. The numbers don't lie. The first stage is ignited all the way out to 5 minutes. Something is wrong because the rocket is not doing what the numbers say. The timer doesn't lie. Timer does not lie. And I know they have this stuff planned down to the millisecond because that millisecond or a fraction of a second could be the difference between you missing orbit and you're basically not going to space, right? It's not like Kerbal where you can compensate. In real life, rockets are strung to the absolute maximum. It does not get any more hardcore than this. You have to get stuff right. Don't get me wrong, it's probably not usually down to the millisecond, but it has to be at least within a second. That's why they call rockets in terms of nominal arrays, because you're never going to get it exactly down to the millisecond. You're never going to get the speed exactly down to the millisecond, right? Or the speed exactly down to the, the meter a second velocity. It doesn't work like that. You can get close, right?
Discovery.
So you said last to me 2 times, and the time you typed last to me 2 times, you could have just retyped this. You type it out again. Neo, 60-month resub. So let's go to 459 and see if we accelerate another 120 kilometers per hour per second. I agree, Synerd. I hate using that. How much under max weight was that sat? Is 3,000. The thing can do 25 tons to low Earth orbit. That thing was 3,000. That is part of the reason why they flew this crazy trajectory. I can't see very well. Is it exactly 6 seconds late by any chance? Maybe the counter on top is T0 liftoff and the time on the infographic is T0 at ROFI ignition. Could there be an engine that messed up during drifto and tow engines burned longer to make up for it? Actually, Salyut, I would say that all those are reasonable possibilities, but I don't know. Yeah. The velocity rate of change makes a huge jump. All right, let's check it. Let's check it. So at 458, we're looking for 120 kilometers an hour per second speed here. So this next number should be 12,970, give or take, at 459. You're a little low there. That's 40 kilometers an hour per second off. Now, Vulcan, do you see that? That could be residual. This could be residual thrust. Where does it get us to in 5 minutes? So we know that 12,970 was the max speed. So I'm going to guess the engine cutoff was right there. And that might be staging like what you guys said. Kilometers per hour to meters a second is easy. Just multiply or divide by 3.6. Yep. General Kenobi. It's the stage 1 shutoff. Yeah, Will, I think you're right, man. I think that's stage 1 shutdown. But check it out, dude. We're way... That 3 seconds is a big deal. The timer don't lie. How much of a speed changes it to from 459 to 5 minutes? Yeah. See, the thing is, guys, I have no other H3 launches to compare this to. I don't know if this is residual thrust showing up in the numbers right there, or if it's supposed to do that, or the staging impulse, so the separation event is accelerating us a little bit. I don't know which one it is. For all we know, staging could be on time here. You know, now that I'm thinking about it, it's really hard to say. That's a huge bump in speed right there at the end, isn't it? That's got to be staging, Aquilux. That's my guess. But even then, that would mean what time is the staging event supposed to happen here? They say that the staging event is supposed to be at 5:04. The rate of deceleration is too high. Yeah, something went wrong, dude. Someone went wrong there during staging. The second stage never ignited, guys. Yeah. Interesting. And it should have coasted for a second to second stage ignition. That's what that says right there. And second stage ignition. That's a little bit of a coast for second stage ignition. Nikita, perhaps. I mean, most rockets have a compensating most rockets have a guidance system that can compensate for off-nominal events like this. That's how inertial guidance systems work. They'll I mean, a little bit into guidance systems. I don't want to get too into detail because... But basically, it's measuring the inertia of the vehicle. And if it'll see that it's not accelerating to where it needs to be, and it should compensate for it if it's any useful avionics. And this is an avionics system on a rocket that we know is not engineered by idiots. You know what I mean? The Japanese can engineer pretty damn well. They're really good at it. So it would compensate for it, but yeah, this looks like the second. Guys, looking at these numbers, and once again, this is a guess. I'm guessing because it's fun. You know, it's fun to see like later if we were right with our hypothesis, right? But you know, they have to go through the telemetry and look. But it looks like the second stage never even ignited. From the data that I'm seeing here, the first stage burned a little bit too long, and first stage burned a little bit too long for whatever reason. I don't know if that's the reason for it to ignite or not ignite. Like, I don't know, but it burned a little bit too long. The second stage never even ignited and didn't even get close. Well, I mean, it did get close. It clearly separated. We saw an impulse there of, what was the impulse at the 5-minute mark? It was like 30 kilometers an hour per second or something like that. It definitely staged, but nothing. Well, yeah, sure, man. Here, let me give you a permit. Yeah, you can post links now. The missile knows where it is at all times. That's right, Pete. Exactly. Inertial guidance systems. That's what the missile is about. That decel does itself reduce at the 504 mark. Could the first stage have been close and caused an engine failure?
Discovery, go at throttle up.
Hey, Dad Joe gifted a sub to Will. Thanks, Dad. Thanks, Dad! Are we 100% sure it's staged? The decel does itself reduce at the 504 mark. It's Aqualex, that's ullage. That's an ullage motor. So, guys, here's a problem when you stage rockets in real life, okay? So, your fuel tank has a bunch of liquid in it, right? And the rocket's under acceleration. When the first stage shuts off, that liquid is in free fall, so it just starts going everywhere, right? You have to find a way during staging to settle all the fluid, all your fuel, your commodities on the bottom of the stage. So if your rocket engine is right here pointing that way, and you stage, what that's going to do is push all your liquid fuel and oxidizer forward if it's liquid, right? Solid rocket second stage, don't listen to this part. But all that's going to go forward. So what rockets do is they have ullage motors on them. It could be a reaction control system on the second stage. It could be a push separator from the first stage like Falcon 9. That's what Falcon 9 does. It pushes the rocket away and then they light the stage. But you need some type of what's called an ullage motor to accelerate the vehicle. The reason why is because you got to settle your propellants. The propellants need to be settled at the bottom because you don't want your rocket engine to ingest gas. Rocket engines, liquid fuel rocket engines are designed to take one thing, liquid fuel and liquid oxidizer. You put anything else in there, the rocket engine blows up, most likely. And that could be what happened. Who knows? Don't know. Too hard to tell. SW Ilkin, 5-month resub. Thank you very much. I try, huzzah. Have a look at Crew 2, for example. Miko's planned at T plus 236, but it happens seconds later, so rockets definitely aren't depending on millisecond accuracy. That's right, Kraken. Yeah, it's not millisecond, it's down to a nominal range, which is why they always say stuff's going nominal. So, the staging could be a couple seconds late. That's okay. I would say 3 to 4 seconds is about the maximum, like, with any rocket. I can say that with pretty big confidence. With any rocket. You miss it by 10 seconds, you're not getting into space. Unless you're way over-engineered. Even NSF in the YouTube chat was confused by the turn. Historia, that was one of the gnarliest maneuvers I've ever seen any rocket do. Yeah, agreed. 6 seconds is a lot. Yeah. I'd say 3 to 4, right? 3 to 4. 3 to 4 seconds off the timing here, you're screwed. And judging by what we're looking at with the acceleration there, I would say we're about 4 seconds off. So, but here's the thing, guys. Even if the computers saw with the inertial guidance system that's on board, if it saw that it was 3 to 4 seconds off, it would still try. It would still try to do it. It just wouldn't make it. Case in point would be like Firefly. That's what Firefly's rocket did. Firefly's rocket basically compensated, but it never made it all the way into space. So it put it in as close of an orbit, as close of a stable orbit as possible. Yes, the guidance systems are that smart. They're really good. That's why it's such like a closely guarded secret. You don't share GNC data with other people. Like, friends don't let friends share GNC data. The thought is that the ullage motor fired, but because it expected to have coasted away from the first stage for longer than it did, if it tried second stage engine start, it'd have been closer than planned. I wonder if excessive proximity could have messed up the start sequence. Well, Aqualux, if it messed up the start sequence, we would see some tumbling. And if we were going to see some tumbling, the numbers up to Ascent would waltz, I guess is the right way to say it. Yes, that's a waltz. It's a good song, too. So you'd see the numbers accelerate and then kind of slow down and accelerate and kind of slow down. It'd be sinusoidal deceleration to apogee, right? So let's take a look. I did say the numbers were unsteady for the event. Let's see. So guys, tumbling would show up in the telemetry by this number kind of accelerating and then slowing down, and then accelerating and then slowing down, and then accelerating and then slowing down. That's how it would show up, because the thing is tumbling end over end, and because the inertial measuring system on board is trying to extrapolate the speed from its acceleration. If you're flipping end over end going up into apogee, there would be times where your acceleration would go like this, or at least that's how the IMU would read it. Tumbling is really easy to spot with numbers, especially if you have a velocity indicator here. So let's see. You'd be able to see it. These numbers would go up and then slow down and then up and then slow down and then up and then slow. Well, actually, in this particular case, they'd go down and then slow down and then go down and then slow down and go down and then slow down. Let's see.
Discovery, go at throttle up.
They're slowing down. It's slowing down and then speeding up. Absolutely. Huh. The song Whippin' Post by Allman Brothers. That's right. It's a waltz, dude. Did you know that? Crazy. Better down, better down, better down, better down. It's a great song, dude. One of my favorites. Yeah, let's see if we can extrapolate its RPM from that, dude. Yes, guys, you can figure out all this from the telemetry. As long as we can confirm that these numbers are real, and we did, we know that they're real from the last launch because we saw an unconfigured IMU when they scrubbed before. And I don't know, that may have been the reason why it scrubbed, who knows. But we know that these numbers are on par, right? That's definitely right. We know that they're live. I mean, they said they were live, so they usually say if it's an animation or not. So if these are telemetry-driven numbers, right? Let's see. Let's take a look. So once again, if the thing is spinning end over end like this, the numbers will accelerate, and then they'll slow down. The rate of acceleration will go up, and then it'll kind of stop, and then it'll go down, and then it'll go up, then it'll go down, like this. You'll see like a varying rate of acceleration here. So if we plot this, right, let's go. We'll start at 518. Screw it. All right, let's go. 518. So we're at 12,604. Okay. What's the deceleration to 519? 20 kilometers an hour per second deceleration, give or take. Hang on, let me back it up. What was that last number? 19. So 582. So if it wasn't spinning, if the thing was just coasting, right, straight up, that this next number at 520 should be around 61, 60, 59, somewhere around there. Close enough. Next one should be at 40. That's exactly 20 right there. Okay. Exactly 20 again. Yeah, it was 19 that time. Actually, right at 3. That's 20 again. So let's get a little more accurate here then. So if this is the case at 23, 12,503, at 524 on the dot, this number should be 11,983. If we're coasting, if it's coasting. Let's see if we can plot this. Or not 11, I'm stupid. 12,483. I'm dumb. I don't know why I pulled that number out of my tail. Excuse me for my terrible math. 83 is right. Okay, that's 20 again. Let's see. It's 20 again. I'm seeing consistent 20. In fact, back a couple seconds ago, it was like 23, 21, and now it's just 20. Let me go a little bit further. 20 again. Oh. Deceleration. That was 17 that time. 17 kilometers per hour per second difference deceleration in that second right there. Now, okay, here's the thing. If the next one is like 15 between 26 and 27, and then the one after that is like 17, and then the one after that is 20 again, then it's tumbling. That means the stage is flipping end over end. So that one was 17 that time. Actually, that was 15. Hang on, let me just go back. Let me just double check. Just want to be sure. $12,443. Yep. 18. Yeah. 43 times is 18. Well, it's like 17 or 18, depending on which tick you want. So that one was different. Let's go. In a second there, that went from 25 to 3. Ooh. Those are weird numbers. As it reaches the apogee, the deceleration numbers will get smaller also? Yeah, of course they are, Bill. We're looking for differences between the second tick, right? Yeah, of course you're going to get deceleration from going to apogee. I'm looking at the rate. The rate should be the same every time. It's not the same. We started, it was like 17, and then it went up to 20, and then it went down to 17 again, and now it's at, that was 22 that time. Because at 5:27 on the dot, we were at 12.425. 5:28 on the dot, we're at 12.403. It's tumbling. Second stage is tumbling. Big problems. That means it's flipping end over end. What if it's spinning in a spiral instead of end over end? Historia, you're saying what if it's doing this? It could be doing that too. That would show up as well. A yaw, uncontrolled yaw. It's definitely not rolling like this. Roll would not show an acceleration like that. So it's either doing this, or it's doing this, or it's doing both, like that. I'd say that's pretty conclusive that the second stage is tumbling. Like a top processing. Bingo. Let's see what the next one is, just to be sure. But yeah, Bill, we're checking the rate. If we're coasting to AP, your trade between kinetic and potential energy should be fairly linear all the way up to AP, right? All the way up to the apogee, which is way over here. That should be a fairly linear rate of deceleration, meaning it's going to be about the same every time. This one is all over the place in terms of difference in velocity. Actually, you know what? That wouldn't be that much of a linear rate, to be honest with you. But you definitely wouldn't see... It should slowly go down over time. It should be like 16, 15, 14, 13, 12, 11, 10, right? Like, now that I'm really thinking about it, it shouldn't be linear. It should be... That's logarithmic. Okay, watching a failed launch and now you guys are crunching legit numbers. Did you really learn this from a video game? We learned the basics from Kerbal, dude. But no, analyzing telemetry is not really something that Kerbal will teach you. I learned this from reading too much about rockets. Did they launch yet? It didn't go, Victory. The second stage didn't ignite. Right now, what I'm trying to use is the velocity and timing data to see if the stage is coasting or if it's flipping end over end. And what I'm looking at here is that it looks like it's flipping. There's some type of yaw pitch rate on the stage, and you can tell because of the difference in numbers, right? Our rate of deceleration is altering. It should be slowly going down. So like at 5:28, we're going 12.403, right? Obviously, this thing is coasting up to apogee, so this should be going down more or less at a similar correlative rate. These numbers of the change in kilometers an hour per second they're not even close to linear. It's all over the place. And if it's all over the place, that means it's spinning. That means there's a rate on this stage that's not supposed to be there. So let's go back. Let's go 5:28 to 5:29. 12.403. What our rate of deceleration was like 17, and then it was 20, 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 and then it was 17, and that one was 25 or 22. That's a big difference. It definitely wouldn't do that. I don't think. Oh, okay, Victory. Yeah, it was 22 on that time. All right, so let's see. 1, 2, 3, 4, 5, 6. That one was 20 that time. Or, well, 19. 19 on that one. Wait, what was that number? Just so I can get this in my head. So 12,384. So that means the next number at 5 minutes 30 seconds should be 12,363, 12,364, somewhere around there. Oh, yeah. That's tumbling. Very slow. Very, very slow RPM.
Discovery,
That's tumbling.
go at throttle up.
Oh, yeah. Absolutely. That was 18 that time. It was 21 before, now it's 18. That's tumbling. Or 16, excuse me. Sorry, doing the math that fast and trying to figure out what the stage is doing in my head is screwing with me. What would make the stage tumble like that? I don't know. The Salyut, I know what could cause it. Gimbal lock, but bad stage ignition, thrust vector control malfunction. Heck, residual first stage thrust, like you suggested, could cause that problem. Hey, Ray, thanks for the raid. Or not for the raid, thanks for the resub, dude. Sweet. You didn't raid that time. Sorry, I'm used to saying thanks for the raid, man, when you pop in. How you doing, dude? Seeing news reports of JAXA sending a self-destruct signal. It's a formality, Rain. They would send the termination signal even after the rocket is re-entered. You send the termination signal to indicate the end of mission, to stop the mission timer. It's a formality. We do that. We do the same thing too. On a seriously morbid note, that's exactly what we did with Challenger. They triggered RSO abort about 20 to 30 seconds after. So at T plus 93 seconds, I think it was 93, RSO abort was initiated. You don't need. It's a formality. Yeah, I mean that happens all the. Yeah, they would trigger a range safety abort even after the mission is lost, just to give you a conclusion endpoint. What's the decision chain for like that? Well, if you don't have an automatic flight termination system, Jeff, it's literally a guy with a button watching monitors. Oh yeah. Humans are still really good at seeing if there's faults. Heck, we can extrapolate the RPM on that stage because of bad staging. We can extrapolate RPM just by looking at a timer and velocity. From here, we could get rate of acceleration, and then we could extrapolate it into degrees a second radian, and you could figure out the RPM from that. I'm pretty damn sure. Yeah. I don't know what axis it would be on. That's kind of hard to say. That would get into a little bit more complicated stuff. But the stage is slowly tumbling end over end. It's spinning around like this. It's one or the other. Does H3 not have an automated system? So, Huzzah, even with, I should have said that a little bit better. Even with automated systems, you still have a manual human backup just in case. Yep. KSP2 Ruzik really reminds you of City Skylines. I love it, Arsenal. I think it's fantastic. Yeah. I mean, but actually getting an automatic flight termination system certified by the range was a big, big hurdle for SpaceX in 2015, 2016, 2017. It was a big hurdle for SpaceX. It was a big hurdle for Falcon 9. The range was super reluctant to have an automatic flight termination system. They didn't want that. But SpaceX proved with data and numbers that it's doable. It's fine. It's good. The automatic flight termination system detected a fault on CRS-11 and terminated the booster. Or not CRS-11, CRS-7, excuse me, and terminated the booster. Rightly so. It worked just fine. That's funny because that ended up being one of the things that qualified an automatic flight termination system, or the automated FTS. They said second stage ignition confirmation was not received, but telemetry still came in. Yeah, Krakens. Yeah, which means the stage didn't blow up. If it blew up, these numbers wouldn't be as crisp as they were. They just didn't get an ignition. That could happen from a bunch of different things. Guys, I don't know. I have no idea what could cause that problem. You have a new rocket, new version of that engine with new parts that are not fully qualified. I mean, this is the qualification mission. It clearly didn't work. So AFDS is hard to do to get a computer to be able to sniff out when something's fishy. That's not something they're good at. I mean, the Mark 1 eyeball and a couple of cameras is still a really good way to do it, and it's a lot cheaper than trying to do an AFDS, but SpaceX is SpaceX, and they were like, nah, screw that, we'll do it. Are there any islands on the trajectory? No, Spaceman, I'm pretty sure they flew out in a way like this to go around everything, dude. Yeah, guys, I mean, judging by what we saw with the stage, Okay, so if this thing was really flipping end over end, that means something exploded. But the fact that we're looking at the numbers and there is a slow RPM on the stage like this, that tells me that they didn't even get to engine ignition. There was never a command for engine start issued by the computer. So something happened. Either the computer issued a command, a wire came unplugged. It's something dumb. I know it is. It's something stupid. This is like something came unplugged during Ascent. That does happen, dudes. It happens. Or it could be in the case of Vega and some bonehead crossed the wires. That did happen once. We were watching a Vega rocket go up into space, right? Second stage ignited, everything is going good, right? They disconnected, they light the third stage, and the thing does this. Turn right down into the ground. Oh, yeah. I mean, it was way up in space, so it pointed down at the ground. What happened was that somebody literally crossed the thrust vector control system cables. They attached positive to negative and negative to positive. So when the engine commanded the rocket to push the vehicle up higher, it pushed it into the ground. Oh, that absolutely happened. Yeah, crossed wires do happen. That happens. Oh, yeah. More than you think. Heck, a Proton launch from about 10 years ago, some guy put the IMU in upside down. Oh, yeah. Hammered it in upside down. So the rocket went to launch, and when it went to launch, the IMU was in backwards. So the rocket thought that the nose of the rocket was this way and the engines were that way. So when it launched, it did this. It flipped over and crashed into the ground. Straight up. It's a Proton launch. Oh, yeah. You'd be surprised how often stuff like this happens. It's always something stupid. It's always a Michael Bolton. I mean, the guy hammering the IMU in was not a Michael Bolton. That's just straight stupidity. The Proton one is difficult to watch, dude. It's just hard to watch. Like, this is that launch. Now, this is not the H3 rocket for anybody that's here. This is just a replay showing that, you know, it's always something dumb. It's always something stupid, right? So here, this one seems to be in slow motion, but we'll play it at 2x speed. Look, see? The computer thinks the rocket is upside down. So the guidance system on it tries to compensate. And when it tries to compensate, this is basically the equivalent of having a docking port or installing your probe core upside down in KSP and then locking SAS to prograde. The rocket will try and flip over. We can mimic this in KSP, which is really funny, actually. Yeah, so the rocket thinks it's upside down. Right? So what the computers are trying to do is orient the rocket correctly. I mean, it's a testament to that guidance system. That's pretty damn good, considering. And aerodynamics obliterate the payload, and then the rocket comes apart. Yep. Even at low speed, that's what aerodynamics do. Oh, you see it rip that thing apart? Oh, that happens. Yeah, pretty much, Aldezert. It didn't know what to do. Oh, yeah? What would the numbers look like on that? I wouldn't. So, Rob Roy, the numbers on that one would be pretty. If I saw the telemetry, that'd be pretty easy to spot. All you'd need to do is look at the altitude and see that the rocket going down after 5 seconds is probably not what you want. I don't think. I would need to see the telemetry in full, but they didn't show the telemetry, unlike the H3 launch. The H3 launch did show the telemetry. So, once again, guys, my money's on somebody crossed the wire or something came unplugged. It's something stupid. The second stage was separated. It did separate, but it was tumbling. Just a very slow RPM tumble like that indicates that the second stage just never fired. The engine didn't fire. It didn't even get to the startup sequence. And that happens when, once again, that happens when something comes unplugged. This stuff happens, dude. It does. It happens. And I'm sure the JAXA and the Mitsubishi people are looking through it right now, and they're figuring out a solution. They'll be back. That's always the case. But yeah, that does suck. It's difficult to watch. You wouldn't wish this crap on anybody. Like, any Kerbal player knows, dude. Any Kerbal player knows when your rocket fails, it's frustrating as hell. All that freaking time you put into the stupid thing, you put it on the pad, it blows up. It's just like, oh, that's great. Lovely. Why the frick do I even try? That hurts in KSP. I can't even imagine what that's like in real life. That probably really sucks. Hope no one has to commit Sudoku. Ah, jeez. That would be terrible. Yeah, exactly, Aqualex. The proton upside down is kind of an extreme example. But the Vega, the guy crossing the TVC wires, positive to negative, and the rocket nosing into the ground. Man, that's just, dude, what are you doing? Ah, damn, hit revert. Yeah, what are you doing? We saw it. Yeah, we saw that, and we knew something went wrong when the frickin' velocity started stop. The velocity stopped because the thing pointed radial in. The acceleration stopped, and I'm like, is that supposed to do that? And then the altimeter went. And then that's actually where I learned that varying numbers from that Vega launch. I learned that varying numbers mean it's tumbling end over end because the velocity was going up and going down and going up and going down and going up and going down. That's where I learned that from, believe it or not. You can discern RPM from velocity change, dude. Absolutely. IMUs do that all the time. That's how a guidance system works. What happened? Sorry, the H3 rocket didn't make it into space. Not Terminator, Giphy. Didn't have enough struts. Yep. All right, dudes. We're getting up to 10 o'clock, guys. So, hey, that sucks, but they'll be back. They'll be back. You don't cut and run when something goes wrong. They'll be back. And in greater numbers. No, actually, the H3 rocket should be launching more because it's going to help support Gateway. So... So, you know, it's a stressful thing, but it happens, you know? But hey, you know what? Speaking of stressful, you want to see something else stressful? You could be that guy. You could be the guy that set off the Halon system. Any A&Ps out there? Any A&Ps out there? You see that? Oh, you could have that guy's job. You know, AFFF. Oh, it's AFFF. You guys use AFFF? Well, you're a squid, dude. That's... I don't know if that's Halon or AFFF. It might be. I don't know. You'd know better than me. Bath time! Oh, God. That's not Halon. Oh, jeez. AFFF is purple? That's AFFF? Halon is a gas? Yeah, that's got to be AFFF then. You're right, fellas. Sorry, I had Freudian slip. This is foam. You're foam. But also, I don't know, Spaceman, maybe. I think it's the Chinese, dude. The Chinese have Beidou, or Beidou. Oh, God. Either way, that's not good. It doesn't matter if it's AFFF. I'm wrong. Don't get me wrong. I'm wrong. It's not Halon. That's either AFFF or foam or whatever. Either way, that's not good for the plane. But at least it's not on fire, I guess. It probably has never been washed, so it needed it. Yeah, that's... It'll buff out. It'll buff out. If it's safe to touch, I want to jump in the floof. The jet needed some me time. Yep. Aerospace. It do be stressful, though. That's terrible, W. I didn't need to know that. Anyway. All right. So, guys, that's going to do it for me through the day. I hope you guys enjoyed the H3 launch coverage. Let's see who we can drop a raid on here. Not a Halon, a raid on. That was a terrible joke. Sorry. Thanks for coverage and analysis. Sure. Let's see. Who's out and about? Who haven't re-rated in a little while? We haven't rated Haas in a little while. Haas has been out and about. Haas is playing some no pixel. He's doing.
All dummies.
There he is.
All
There's
dummies.
my guy. Okay. Yeah, gotta be careful with the music. Let's go see what Haas is up to. A large hadron. Got him. Guys, go over there. Oh, Mitsubishi. Oh, Mitsubishi. Thank you. All right. You do a significantly good job on this stuff. Thanks for that. I try, man. With your help. It's only with your help that we get this good, and you know. But anyway, let's go see what Haas is up to, dudes. I'll see you guys tomorrow at noon. We'll try to get that Eve flyby off. We'll see where it takes us. So, go see what Haas is up to, guys. Thank you very much for watching, and I hope you have a good night. I'll see you.